When you step outside on a clear night and tilt your head toward the sky, something ancient stirs inside you. It's a quiet feeling, almost instinctive, as if some distant memory buried in the human spirit awakens the moment you see those tiny points of light scattered across the darkness. For thousands of years, people have looked up the same way you do now, trying to understand what those lights truly were, what they meant, and what they had to do with us. There's something humbling, almost overwhelming, about realizing that everything you know, everything you've ever touched or loved, exists under that same cosmic canopy. And the strangest, most beautiful part of all is that the stars you see overhead aren't just decorations in the night sky. They are enormous nuclear engines, blazing suns scattered across the universe, each one older, larger, and more mysterious than the last. Most people don't think about the true scale of a star. It's natural. The human mind isn't built for it. We evolved to understand trees, rivers, mountains, things we can walk around, touch, measure with our own senses. But stars aren't like that. They are so impossibly big that even the numbers themselves lose meaning. A typical star, like our sun, burns at millions of degrees in its core, crushing hydrogen into helium with such relentless pressure that the energy released could vaporize entire worlds in seconds. And yet from Earth, that star looks like a calm golden circle you can glance at in a drawing. The truth is that stars are so far away, so overwhelmingly distant, that the very light you see from them has traveled across time just to reach your eyes. Some of it began its journey before humans existed. You may look at a star and see it shining steadily in the sky, unaware that the star itself might have died thousands of years ago, its light only now arriving here, as if giving you one last echo of its existence. In the United States, many people grow up with stories about constellations, tales passed down from cultures around the world, even if they don't realize it. Orion, with his bright belt, is familiar to just about everyone in North America. Children look up and spot the three perfectly lined up stars, and something about that arrangement feels almost comforting. Generations before them did the same, long before there were city lights or satellites or airplanes to distract the sky. There's something charmingly American about camping trips under the open sky, sitting around a crackling fire, pointing upward and letting imagination fill in the gaps between the stars. Some families still tell the old legends. Others just quietly appreciate the calmness of the night. But nobody can deny that stars have a way of grounding you while simultaneously reminding you how small you really are. Scientists often say that studying stars is like studying time itself. The further into space you look, the further into the past you're actually seeing. It's a concept that feels almost like a trick at first, but it's the truth. Light doesn't travel instantly. It moves at a speed that, while incredibly fast, still takes time to cross the vast distances of space. The nearest star to us, Proxima Centauri, is more than 4 light-years away, which means the last time the light from that star left its surface, you were 4 years younger, the world was 4 years different, and everything that happened since then unfolded long after that beam of light was already on its way. And that's our closest neighbor. Many of the stars you see are hundreds or thousands of light-years distant. It's like looking at a photograph of the universe taken centuries ago, except the image is still coming in wave after wave of starlight. If you think about it long enough, it becomes almost emotional. You, a single person on a small planet, can stand outside at night and literally see the past with your own eyes. No telescope required, just your sight and a clear sky. It's one of the few experiences where human limitations become a kind of gift, letting you glimpse something otherwise impossible, the universe not as it is now, but as it once was. There's a reason NASA, American universities, and observatories across the country dedicate decades, sometimes entire lifetimes, to studying stars. Not because they're beautiful, though they are. Not even because they're mysterious, though they definitely are. It's because stars hold the secrets of how everything came to exist, including you. The atoms in your body, the iron in your blood, the calcium in your bones, the oxygen in your lungs, We're all forged inside ancient stars that lived and died long before the sun was born. When those stars exploded, they scattered their elements across space like cosmic seeds, drifting through the galaxy until they eventually collected into new planets, new moons, and eventually, new life. That simple fact, that you are literally made of stardust, is one of the most powerful truths science has ever uncovered. Carl Sagan said it beautifully decades ago, and Americans still quote it today because it feels poetic in a way that's hard to deny. You aren't just living in the universe. You are part of it, a continuation of something that began in the heart of a dying star. Stars come in all shapes and sizes, from tiny red dwarfs that burn slowly for trillions of years to massive blue giants that live fast and die violently. The sun is somewhere in between, an ordinary star, not too big, not too small, not too hot, not too cold. And in that ordinariness lies the miracle of our existence. A slightly hotter or larger star would have burned too intensely. A smaller, cooler star might not have provided enough energy. Our star is perfectly balanced, and because of that, Earth became a place where oceans could form, where life could take root, where civilizations could eventually rise. Astronomers across the US spend countless nights looking for planets around other stars, hoping to answer the biggest question of all: are we alone? And every year, we get a little closer to understanding. Thanks to American-built observatories like Keck in Hawaii and space missions like Kepler and TESS, scientists have discovered thousands of exoplanets. Some rocky, some gaseous, some so strange they barely seem real: planets with raining glass, planets with two suns, planets covered in oceans deeper than anything on Earth. And hidden among them, a few lie in the habitable zone, the region where temperatures might allow liquid water. It's hard not to imagine that somewhere out there, orbiting some distant star, there could be a world with mountains and rivers and skies lit by constellations we'll never see from Earth. The funny thing is, the more we learn about stars, the more we realize how much we still don't know. American astronomers joke about this all the time, not out of frustration, but out of excitement. It's like opening a book you thought you understood, only to discover that half the pages are blank, waiting to be filled in. Some stars pulse like beating hearts, brightening and dimming in rhythmic cycles that tell stories about their age and temperature. Others spin so fast that they flatten out at their poles. Some even swallow nearby planets, leaving behind chemical traces that scientists can detect across space. It's wild to think about, a star eating a world like some kind of cosmic predator. But it happens, and the evidence is there, floating in the spectral fingerprints we capture through telescopes. Then there are neutron stars, the remnants of supernovae, spinning thousands of times per second, each the size of a city yet so dense that a single teaspoon of their material would weigh as much as a mountain. When Americans first detected pulsars in the 1960s, they actually thought they might be signals from aliens because the pulses were so precise, so regular, that nothing in nature seemed capable of producing them. One astronomer even labeled the first recording as LGM1, Little Green Men 1, half as a joke, half out of genuine bafflement. It's those little moments of humor that remind you scientists are human too, stumbling across discoveries that shake the world, often by accident, sometimes late at night with cold coffee and tired eyes. And then there are black holes, the strangest children of dying stars, places where gravity becomes so intense that not even light can escape. Americans often imagine them as monsters lurking in space, devouring everything nearby, but black holes are simply the natural end of extreme stellar evolution. They're terrifying, yes, but also elegant, beautiful in a way. And thanks to American observatories and global collaborations, we now have an actual image of a black hole, a photograph of something once believed to be purely theoretical. Think about that for a moment. A creature of light made by stars, capturing the shadow of something that swallows light itself. What makes stars truly magical is that no matter how much science explains them, they never lose their wonder. You can know all about fusion, gravity, stellar evolution, red giants, white dwarfs, metallicity, rotation rates, spectral classes, and still look up on a quiet night and feel that same awe humans felt 10,000 years ago. In a world that changes every day, where technology evolves faster than we can keep up, stars remain a constant. They don't rush. They don't panic. They don't demand. They simply exist, burning silently across the universe, marking the slow passage of cosmic time in ways we can barely comprehend. Some nights when the world feels too loud, too chaotic, too uncertain, Americans step outside, breathe in the cool air, and look up. There's something grounding in that simple act. The problems of the day seem smaller, somehow less permanent. The stars remind you that life continues, that the universe goes on, that billions of years came before you and billions will come after. It's not depressing, it's freeing. It gives perspective. It gives peace. And maybe that's the real meaning of stars. Not just their science, not just their beauty, but their ability to connect us across cultures, across generations, across continents. Whether you're standing in a quiet American suburb, a desert in Arizona, a mountain in Colorado, or a beach in California, the stars above you are the same stars seen by ancient people who had no telescopes, no electricity, no understanding of physics, only curiosity. The same curiosity that drives modern astronomers today. The same curiosity that makes you look up now. We study stars because they tell us who we are, where we came from, and where we might go next. They are the childhood of the universe, the engines of creation, the storytellers of deep time. They ignite, they live, they transform, and they die, and through their lives, they shape everything we know. Even the end of a star becomes a beginning for something new. Perhaps that's the most comforting truth of all. Somewhere out there, beyond the reach of any telescope, new stars are forming right now, deep inside clouds of dust and gas. They spark into existence, faint and fragile at first, then grow brighter, stronger, ready to illuminate whatever worlds may orbit them billions of years from now. And as you listen to this, somewhere in the night sky, a beam of starlight is crossing the darkness, traveling through the void, heading toward Earth. It may have started long before you were born, but tonight it will reach you, a tiny, ancient message from the universe, reminding you that you're part of something vast, beautiful, and eternal.